So we finished the classical method more or less on the last one. I didn't do step 6 yet. Step 6 yet. There we go. But I mean, I can say it now. It's going to be the same for both methods, so it doesn't really matter. But basically, there is enough evidence to support the claim that male and female 7th grade students who are smokers are significantly, let's put it that way, significantly different in their addiction to nicotine levels. All right? Because we rejected the null hypothesis, there's something statistically significant going on. All right, now let's go back and do it all again. Sorry, but with the p-value method, which I infinitely prefer, but that's all right. All right, so we need to have a picture here. Because it's a two-tailed test, it's going to be that picture. Let me go grab one. All right, luckily for us, we know since it's the p-value method, we actually know that these are t zeros. So when you're working with the classical method, those are t alphas, and you have to go find them. But for us, we know these are 3.29, whoops, if I can remember what it was, 3.295, there we go, 3.295, and this one over here is negative 3.295. They're the t zeros that you found in step, oh God, I've got to stop doing that. I know what I'm doing, but negative, if I press the minus sign, it keeps doing that. Anyway, it's annoying. Okay, so there it is, but I need to find the p-value, this sucker up here. I need to find what both of these two tails add up to. And I will use Excel, and then I will use StatCrunch as well. And I'll try to do it right. So, all right, so it's the t.distribution.2t. It's this one, because you're doing a two-tailed thing. Now, the thing about it is that this wants the positive value, if I remember correctly. So you got to do absolute value of this test statistic. Oh, it would help if you did a parentheses with it. There, left parentheses, there. It wants the positive number. It won't be happy unless you give it to it. And you do the smaller of the 2 degrees of freedom, which for us was 150, take away 1. There we go. That's the p-value. And again, that's an approximate. The instructor who wrote the book is kind of flubbing through the degrees of freedom argument just a little bit, and it's because it can get really complicated. So we're just going to pick the smaller one and go with it. All right, let me see if I can remember how to do it old school Excel. So it's tdist, which is a much weaker function. Boy, I hate this function. And it wants, I think, again, the absolute value of that number. I think it also wants a positive number. And it wants degrees of freedom, which would be 150, take away 1. And it's a two-tailed thing, so you type comma 2 and cross your fingers. Yay! There you go. So that's how to do it with the old school Excel. But both of them need that number to be positive. So if your test statistic is not positive, like this one isn't, you'll have to take the absolute value of it and make it positive. All right, so there's our p-value, 0.00122. Ugh, where's my, there it is. All right, so I'm losing my mind. There it is. P equals 0.00122, right? All right, so the whole thing I will copy and paste into the video sheet right here. I'll delete all of this because we don't need any of that. All right, and we are going to reject null hypothesis, right? So we reject the null because 0.0 p equals 0.001 is less than alpha, which was 0.05. Now, you're thinking to yourself, well, that doesn't seem any easier. Why do I like it better? Well, I like it better because of StatCrunch. So let me bring that up. There it is.